Okay. So I'm going to be looking at this right here and going through what I believe is going on, sort of explaining what these commas mean, because I don't really think I've went over that much, and what I think this whole thing means. So we have a vector space, um, f infinity. Okay, so in this vector, there are infinite x points. Okay, well, because it's infinite, right? So you have x1 at x2, and then these three dots mean it goes on forever. So x1 to x infinity, right? So these are separate points um, in f, right? So k x at k, right? It's like when we were doing macro and it was like something at time t, right? This is x at 1, this is x at 2, this is x at k. So x at k is in f for k equals 1, 2 until infinity, okay? So let's say we've got x1, x2 going to infinity, and then we have y1, y2. Well, if we wanted to add these two things, and this is where the commas start to matter, is because you're not just adding every single point. That's ridiculous. You're adding only the same points. So x1 and y1 get added, and x2 and xy and sorry, oh my gosh, x1 and y1 get added, x2 and y2 get added, and so on and so forth. Okay, so it has to do with the point that it's um, the point that it's on. So in this case, when we're multiplying by a scalar like lambda or lambda, I don't know how to say it, but when you're multiplying, then it goes into every single point, right? So this gets multiplied into x at 1, x at 2, x at 3, and so on and so forth, okay? So that's what that's about. And this last line is correct until this box here. I'm going to call this box, this is Matthias, speculation. Okay? Just a little heads up, I'm just reading this textbook and trying to teach myself linear algebra. Okay? I don't, sorry, is this linear algebra? What even are we doing? Yeah. So, just a little warning. I'm not being taught like a course or anything. I'm just seeing what I can learn. So this is my speculation about what this sentence means. So it says in the textbook, which is linear algebra done right, f infinity becomes a vector space over f, which is, I'm assuming, kind of means f is in f infinity, which makes sense because if f infinity is the entire vector space that can be expressed, like infinity is the largest number, then any other f has to be inside of f infinity, right? Like if you had f, f, 5, or f, just, anything, fn, um, anything f, well, it's going to be like, okay, maybe if you said like f infinity plus 1 or something, but that's stupid. I don't even want to think about that right now. Um, yeah, that's dumb. I might just cut that one out, or I might keep it in there. So I think maybe that's kind of like a funny thing to say. But yeah, the last sentence, f infinity becomes a vector space over f. So does that mean that F is within F infinity? I think so. I think that's a, but it is a Matthias speculation. This is not written. This is not written in the textbook. I think that's true though. But everything else here is 100% correct. I took it out of the textbook. It's an example, and I think it's pretty cool because it shows you sort of what the commas are all about, and when to where and when to do your math. So yeah, that's done. That is a video. I hope I was in that video the whole time. I was kind of like coming off the side there.